Here we are at 5.2, the second part, 5b. This time we're going to look at dividing radical expressions. When you're dividing radicals, you divide the coefficients and then you divide the radicands. You can only divide radicals that have the same index, meaning you can't divide cube roots by square roots. In example A, we have 4 root 6 over 2 root 3. 4 divided by 2, the whole numbers, is 2. Root 6 divided by root 3 is root 2. We're done. Can't simplify anything any further. For B, 18 divided by 3 is 6. Cube root of 20 divided by the cube root of 5 is the cube root of 4. Nothing can be simplified. We're done. Lastly, 3 divided by, well, that would be 1. Is 3. 22 divided by 11 would be the square root of 2, and m to the 5th divided by m to the 3rd would be m to the power of 2. Now before we finish this, let's look at why we can say that. Well, m to the 5th divided by m to the 3rd means that we have 5 m's times together on the top, 5 times 3 m's times together on the bottom. Now we can cancel. Divide m's into the top and the bottom again and again, and you're going to be left with m squared on the top, and that's the same as m to the 5th over m to the 3rd. The shortcut that we've learned is that when we're dividing with the same base powers, we can subtract the exponents. So that's where we come up with m to the 3rd over m to the 5th divided by m to the 3rd is m to the power 2. Conversely, if it was the other way, m third over m to the 5th, we'd cancel 3 m's on the top with 3 m's on the bottom, which would leave us 1 over m squared. Or, if we subtracted the powers, it brings into account the negative exponent law, which says that's the same as m to the power negative 2. Now to finish our question, 3 root 2 m squared is 3 times root m squared times root 2, because I can find the square root of m squared, and the square root of m squared is m, so our final answer is 3m root 2. Okay, we're going to continue. This time what we're going to do is rationalizing our denominators. It is never allowed when we're working with radicals to leave a square root or a cubed root in the denominator. What we do is we rationalize it. And there's several ways of doing that. The simplest of the cases is where we have something like root 7 over root 3. We can't leave root 3 in the denominator. So what we do is we multiply the top and the bottom by root 3. If we multiply the bottom by root 3, we're going to multiply the top by root 3. And in the bottom, we're going to get root 3 times root 3, which is root 9, or 3. And at the top, we're going to get root 21. That's it. Cleans it up, we're done. In the second example, we have 5 over 2 times root 2. When we have 2 times root 2, all we have to do is multiply the bottom and the top by root 2. If this occurs, we're going to get 2 times root 4 on the bottom and 5 root 2 on the top. And root 4, of course, is just 2. So the bottom is going to be 4, the top is going to be 5 root 2. For a binomial denominator that contains a square root, you multiply both the numerator and the denominator by a conjugate of the denominator. Well, the conjugate is going to be the same two terms, except the sign between them is going to be opposite. If it was 4 minus root 6, we'd have to multiply the top and the bottom by 4 plus root 6. That's what we're going to do. Four plus root 6 is the conjugate of 4 minus root 6. Now in the top we have to go 5 root 3 times 4 and 5 root 3 times root 6 using the distributive property. 5 times 4 is 20 root 3, and 5 times root 3 times root 6 is going to be 5 root 18. On the denominator, you got 4 minus root 6 times 4 plus root 6. We have to go ahead and FOIL that. 4 times 6 will be 16. Then we've got 4 plus root 6. Then we have 4 minus root 6 minus root 36. We can simplify some of this. The root 36 will become 6. And the bottom, 4 root 6 minus 4 root 6 is going to disappear. But on the top, of course, let's go there. Root 18 is root 9 times root 2, which is 3 root 2. So now this will clean up to be 20 root 3 plus 15 root 2 over the 4 root 6 minus 4 root 6 is going to disappear to leave you with 16 minus 6, which is 10. Now we can simplify this a little bit further because 10, 20, and 15, the three terms, can all be divided by 5. And that'll leave us with 4 root 3 plus 3 root 2 over 2. And that's our final answer. For our next one, we have 2 plus root 6 on the denominator, so the conjugate would be 2 minus root 6. So we'd have to multiply the top and the bottom by 2 minus root 6. If we multiply the top now, we'd have to FOIL that. 2 times 3 will be 6. Oh, we'll do the bottom first, of course. 2 times 2 is 4, minus 2 root 6, plus 2 root 6, and minus root 36 on the top. We're going to get 6 minus 3 root 6 minus root 4, no, 2 root 2, that doesn't have a root sign on it, and minus root 12, plus root 12. Geez, start reading. 36, root 36 becomes 6. Negative 2 root 6 plus 2 root 6 will cancel. And on the denominator, 4 minus 6 will leave me with negative 2 on the bottom. The top isn't going to clean up so well, but we can simplify the root 12. The root 12 is going to be root 4 times root 3, which is 2 root 3. Now that still leaves us with 4 terms on the top. 6 minus 3 root 6 minus 2 root 2 plus 2 root 3. That's all we can do. We're done.